We discussed before a little bit about centripetal acceleration. Now we'll discuss the factors affecting centripetal acceleration. We said that circular velocity is an important factor affecting the centripetal acceleration. And we said if there is an object moving from point A to B, we were talking about the little rock previously, and he moved in a distance delta D, and you have velocity VA at the instant A and velocity VB at instant B. Points A and B are at the same distance from the center of rotation, and you have an angle of theta between point A and B for the displacement of object. We said we take a vector analysis for the velocities. We can see VB and minus VA, and we draw head to tail, we will find delta V. Somehow the triangle that represents the distance between point A and B from the center and the delta D is similar to the triangle where you are talking about the direction of the vectors for velocity VA, VB, and delta V. If you equalize them together and do some simplification and needed algebraic mathematics, you will be able to find that the AC, centripetal acceleration, equals V squared over R. It is important to mention that centripetal acceleration is not depending on mass in this case. Same as the gravitational acceleration, it's not depending on mass. Dropping a ball and a marble at the same time in the empty space, they both would reach at the same time, ignoring friction. Same thing here. Centripetal acceleration would be the same, doesn't matter how big or small, how heavy or light the object is. They will always be pulled in a certain acceleration towards the center of rotation regardless of the mass. But in the real world, we have friction, air friction, and we have many factors affecting the circular speed and the centripetal acceleration pulling towards the mass, so these numbers vary. It's important to keep in mind that in the ideal world, centripetal acceleration is not depending on mass. Equation for centripetal acceleration can be represented as well as V squared over R. Let's take an example. If we have a DVD disc has diameter of 12 centimeters and a rotational period of 0.1 second, find centripetal acceleration at the outer edge of the disc. Then you have here D equals 0.12 meters, T equals 0.1 seconds. Find AC. So in this case you have the diameter, not the radius. Diameter D equals 0.12 meters. And the cycle or the period T equals 0.1 second. We know that the R is D, the diameter over 2. If this is the diameter passing through the center, then R is diameter over 2. 0.12 over 2 would give you 0.06 meters for R. And we know that T as 0.1, replacing the equation for the circular velocity. And that would give you 2 by R over T to be 3.77 meters. Now the AC is V squared over R. Of course, it means the circular velocity. 3.77 squared over 0.06 would give you a centripetal acceleration of 2.37 by 10 to the power 2 meters per second squared. Other factors affecting centripetal acceleration. We said mass is not affecting centripetal acceleration, but it influences the force needed to move the object in a circular path. As we know from Newton's second law, the net force is product of mass and net acceleration. So centripetal force must be the product of the mass and the centripetal acceleration. So if you do an analysis, F net equals the mass by acceleration. F centripetal equals mass by acceleration of centripetal. The centripetal force pulling the objects toward the center would equal mass by V squared over R. Same as when we talked before about the gravitational force, it is related heavily on mass, but the gravitational acceleration is not related to mass. That's the difference between AC and FC versus G and FG. Exact same thing, but you're talking about circular motion and an object moving in circular path. We have a problem saying determine magnitude of centripetal force, not acceleration, the force, by the rim of a sporty wheel on 45 kilogram tire. The tire has 0.48 meters radius, rotating at a speed of 30 meters per second. So the mass 45 kilograms, radius 0.48 meters, circular velocity or circular speed 30 meters per second, find the FC. We know FC equals m by v squared over r. We have m 45, keep it as kilogram to be consistent with units, multiplied by 30 squared over 0.48. That will give you the centripetal force to be 8.44 by 10 to the power of 4 newtons.